Hi, Srini.
Hello, Chair.
How was your day?
Fine. Teacher want
If you want.
to quiz and essay.
And tomorrow, if you want to do well, as I said to you, you better study and then review the past year paper. The objective one,
Yes, teacher.
especially
Today I was studying.
multiple choice.
Still studying. Yep.
Right? A lot of formulas you have to memorize. You're going to do well.
Teacher, but your notes, right, teacher?
Any
Not the
comment?
revision notes, the complete notes. That one got the derivation. You wrote the derivation there.
Very brief lah. Very brief. I just put some notes there to just guide you how to derive. That's all. It's not supposed to be
Okay.
right? Just the essential point that you need to remember. Then derive.
Okay.
Tomorrow no derivation. Tomorrow is basically just multiple choice as well. Okay.
Yes.
What you want me to show you? What question you want to ask?
Number 2.
Number 2.
But Chair, you're right, Chair. When I do question, then I don't feel afraid to answer actually.
Then you won't feel frightened if you do the question. Then you're more confident.
Because I'll be more used to the fact that this is how they ask.
That's right. If you do that, you find it easier. If not,
It's
you
like consistently have to do practice. Yeah.
If you don't do it, you lose confidence, then you frighten. Then there's no progress.
Yeah, Chair, like Chair, like today, Chair, another subject that you have to do graph every time. I always scared to do graph, but today I did graph. I confident. Now I feel I want to do graph again.
Yeah, that's why I say you have to have confidence. Okay. Let us go to
exactly for exam another 31 days, Chair. Exactly.
We still need one or two more weeks. That's all. So that you can prepare yourself already. Unless you want, you want me to nothing already. Unless you got question to ask. Yeah, I think next week or the following week will be our last meeting already. After that, you can study yourself.
Oh, okay.
Unless you got question you want to ask.
Yeah. I may have question to ask, Chair.
A positive charged particle P and negatively charged particle Q are projected into a magnetic field at the same speed. If the magnitude of the charges are the same and the mass are given there, right? MP is twice MQ. Which diagram shows the correct path of P and Q? Okay, so if they are the same mass, then it should be this one. It should be A. So applying your Fleming's left-hand rule, right? Your field is going in, your current is going up, so the force is to the left. You should be able to tell. So P is going to the left. Then after that, you have to go to derive the formula, use Fleming's left-hand rule, right?
Teacher, right-hand rule they use for what?
Right-hand rule is for induced EMF.
Okay.
Okay. So it cannot be, answer cannot be C, cannot be D, right? Only A and B, that's all. Then you have to go to the physics involved, right? Derive the equation. As I said, not memorize too many formula. Magnetic force provides centripetal force. Magnetic force, centripetal force, cancel the V. We are interested in the radius. Radius is, right? Take that one up there, BE down. Then you can see that double the mass, double the radius. Okay, so answer is A. Okay.
Okay.
Next question.
Question number 4.
Question number 4.
It's just the teacher.
Yeah,
Do you think I may pass this exam, teacher?
it's really up to you already, I say. If you put in extra effort, you should be able to do well. You should be able to pass. But if you still like last semester, then you will get the same grade as last semester. So it's up to you the last few weeks to put in the extra effort because you have less topic to study this semester.
7 topics.
So I cannot do anything for you. It's you who have to put in the effort. Effort must come from you, not me. I can teach you, that's all. Answer your question, guide you, that's all. Okay, this one, an electron move with a speed v near a paramagnet. Which diagram shows the electron experience maximum force? Remember, maximum force, the field must be perpendicular to the velocity. Right? So it cannot be A. Right? Most likely it's B. Cannot be C because it's at an angle. Right? There's the direction of field is at an angle. How about this one? Donkey. Donkey, the field and the velocity same direction, so no force there. Right? A is false, no force. B is true. C is also, D is false. So answer is B. Okay or not? Anything not clear?
No, I'm okay.
Okay. If okay, then next question.
No, teacher, I mean, how do you read it, teacher?
As I say, you have to look at the field.
Okay.
Right? Yeah, the field is going straight. Velocity is straight. So no force here. This one, the field doesn't matter north or south pole. Right? The field is going straight. If the velocity is perpendicular,
That becomes 0.
then the force is largest. BQV. Right? Force is BQV. Whereas this one, the field is there. That's the field. At an angle to the velocity. So it cannot be the maximum force. Whereas here the field and the force same direction. So the field and the velocity same direction, so no force. Right? That's how we decide. Okay. Next question.
Okay. 5.
When a point charged with magnitude Q move with a velocity V in a magnetic field B, a force F acts on the charge. Which diagram shows the correct orientation of force relative to velocity and B and V? Okay. The field is going in, left-hand rule. Field is going in. Current, there's your current. Right? If it's going to the right, cannot be. The first one, A, cannot be right. Right? And then you go to check on B. Right? Field is going in, current is going down. So if positive charge, then the force will be to the right. Cannot be wrong. Then you go to C. Field is going in, current is going to the right, right? Opposite to the velocity. Right? Opposite to the velocity. So the force is going up, wrong. How about, right? So if this must be correct already. Okay.
Okay.
Can?
Can.
Next question.
7.
7. Copper rod PQ
Mm.
of density that and cross-sectional area given is suspended horizontally between two permanent magnets with magnetic flux density. That one, as shown in diagram. What is the current I flowing in the rod so that the tension of the supporting wire is reduced to 0, no tension. Right? Suspend horizontally. Suspend horizontally between the magnet there. Between magnet there. Okay. Current. So the current passing through. What is the current flowing? So in this case, there is magnetic force. Right? Your weight is pulling it down. Remember this, you are looking for plane view. So in this case, the weight is pulling it down, right, into the page if you like. So you must guess your last semester work. Mass is volume times density. Volume is cross-sectional area times your length of the wire. Okay, so you can calculate since you are given the value, cross-sectional area, length is not given. So put there. Density is given, and then G is 9.81. Right? Can calculate that one out step by step. Okay, so into the page is to the ground. Then apply Fleming's left-hand rule. Right? Fleming's left-hand rule. Your current is going from left to right. The field is going up. So the magnetic force is coming out of the page or going upwards. So magnetic force equals to weight, right? For equilibrium. Sorry, weight of rod, not road. Right? So that's your weight. There's a magnetic force, PIL. L and L can cancel off. Right? Put in your value for P. Okay, L and L can cancel off. Then you can calculate your I. Take this one cross multiply downwards there. Use your calculator. Can?
Can.
This type of question, don't need to go too far about Fleming's left-hand rule. Just know that magnetic force equals to weight. And the weight is going to be equal to magnetic force, and the tension will be more or less 0. Okay, next question.
8.
Conductor of length 0.15 meter carry a constant current I flowing at an angle of 30 degrees to the magnetic field 1.8 Tesla shown in the diagram below. The cross-sectional area of the conductor is 2.5 cm square, and the charge carrier density is given. The magnetic force on the conductor is 4.4 Newton. What is the free velocity of the free electron in the conductor? Okay, so go to your magnetic force first. Right? When it comes to free velocity, you must go to your current, NEAV. Remember, it's a formula. Then go to magnetic force at an angle, VIL sine theta. Then replace your I, right, with NEAV. That's what we get there. Then you want to find V, free velocity. Take the other terms, cross multiply downward there. That's what we get. Then put in your value. Right? There's a force there. And then your B is 1.8. N is given. There's your N. Right? There's your N. And then your E, charge of electron, get from your data sheet. A is area, cross-sectional area, convert it to meter, and 10 to the power minus 4. Right? And then your length is there. Right? Angle is 30. Calculator value, wrong key. Okay.
Okay.
Next question.
9.
Okay. Copper rod of length 10 cm. There's a copper rod. Right? Focus on the black one. That's the one that's moving. Located on the two horizontal metal strips. These are your metal strips. These are your fixed ones, which are connected to battery. Shown in the diagram below. The magnetic field B, right? B is coming down. 2.0 Tesla is applied vertically downwards. If the limiting static friction between the copper rod and metal strip is 0.5 Newton, what is the minimum current that will move the copper rod? Right? Remember, this is your friction. So it means the minimum force is the same. Right? They are in equilibrium. So for the applied force and the frictional force must be the same. Then you just give it a push and it will move. That's all. Right? Magnetic force equals friction. That's all. Right? So your force is BIL for magnetic force. Take your, you want to find I, take your BL down, multiply, put in your value. Right? Force. Right? And your frictional force. B is 2. B is 2. Your L change it to meter. 0.1. Calculate out. Answer is B. Okay, next question.
11.
A region of uniform magnetic field in the minus Z direction, right? They are very kind. Plus Z is into the page. Minus Z is coming out. Sorry. Right? Uniform magnetic field in the minus Z direction. Oh, sorry. Z is coming out. Positive Z is coming out. Minus Z is going in. An electron enters the magnetic field in the Y direction. That's your Y direction. What is the direction of the magnetic force on the electron due to the magnetic field? Okay, use your Fleming's left-hand rule. Electron. So it means that the current is going down. Right? Field is going in. Current is going down. Right? Current is going down. Field is going in. So the force is to the right in the X direction. Can. Okay.
Wait, I don't understand this positive X, positive Y, negative X, negative Y.
This is an electron. So the current
Okay.
is going down. Field is going in. Right? Field is going in.
Okay.
Magnetic field is going in. Yeah. And then current is going down. Current is going down. Field is going in. So the force is to the right. Look, the thumb is pointing to the right. Yeah.
Okay.
Next question.
Yeah, 12. Yeah.
Two thin current carrying conductor of infinite length are fixed perpendicular to each other in the diagram below. The resultant magnetic flux density at P is, that's your P, right? Distance is given you in meter, right? So you need to know that. Right hand grip rule, current is the thumb. The fingers are your direction of your current. So in this case, right? Sorry, this is in cm, not in meter. Right? Field due to I1, this is your I1. Right? Use your thumb there. Use your right hand curve rule. Right? At P is coming out. Right? It's coming out. P is coming out. Then put in your value for your current. Right? Current is 8 mu naught 2 pi. And then this one is your distance. Right? You are looking at I1, so that's your distance 2.8, change it to meter. Then calculate for I2. This I2. Right? I2 is there. Current is going up. So it means that at point P is going in. The field is going in. Same, mu naught. Right? 4.5. Right? I1 is given you as 8. I2 is 4.5. Put it in there. 5. Right? Don't need to calculate. Right? Leave the pi there because pi and mu naught will cancel off. Right? Don't need to calculate. So calculate the others. Okay. If not, you can take out common factor afterwards and calculate at the end. No? So the resultant one is going in, one is going out. So it's subtract. No? Resultant field, right? Outwards. Since outward is larger, take outwards. Minus this one. Okay, mu naught is a common factor in both cases. I take it out. Pi is a common factor. So I only left with 143 minus 56. Okay. Next question.
13.
Two concentric coil or radii 2.0 cm and 6.0 cm respectively as shown in the diagram below. So is the force attractive or repulsive? Yep, it's the force attractive.
Attractive.
How can it be attractive? If you've forgotten, then go to charge. Like charges attract. So like current repel. Okay, opposite to current, opposite to charge. Each coil has 100 turns. If the small coil and the big coil carry a current of, it's written for you, 2 ampere and 6 ampere, respectively in the direction as shown. The resultant flux density at center. Okay, same thing. Right? Use your right hand curve rule, and that's the formula to calculate. At the center there, right? For the smaller coil, this one, right? Just hold on to one, just put your current, just hold on to one side. Current, so it's coming out, right? The field is coming out, right? Just hold it up, the current. If you look at the right hand current, this current there, this current there, right? The thumb is going up, so the current is coming out of the page, right? For the large coil, the same thing. You can look at this side there, right? It's going in, right? It's the circle there, going in. So take out the common factor, mu naught and 2 can take out. N also can take out actually. I've forgotten to take it out. Then what is left is I and R. Right? So that's your I. That's a 2 one. Right? Subtract because they are in opposite direction. And then 2 cm, change it to meter. And then the other one is 100. And then current is 6. Distance is 6 cm, change it to meter. Simplify. 0. A. Okay.
Hello?
Yeah, yeah. I'm waiting for you. What's the next question?
Yeah. 1 minute, sir. Next question is 15.
15. Okay. Current I, the current in the positive x direction, flows through the conductor in direction of positive x direction. Magnitude of the force per unit length experienced by the conductor is 0.2 Newton in the direction of y. So that is your force. If the current is 10 ampere, which statement is not true about the magnetic field? So first thing, apply Fleming's left-hand rule. Right? Your force is going in. Your current is going to the right. So it means that your field is going down. Can or not? In the negative z direction. Yeah. Can? The force is going in. Your current is going to the right. So the magnetic field is going downwards there. Okay. Then after that, go and calculate. So it's in the negative z direction. Right? Calculate your field. Force is given. That's your force. That's your force per unit length. That means length is 1 meter. And the current is 10 ampere. Okay. So you want the one that is false. So C is a false one. So you can see roughly the answer is B or C only, because both of them are contradictory to each other. Right? So the others you don't need to check usually if you want to go fast. Okay.
Okay.
Right, 10 minutes time we have to stop already. Then we'll go to structure. Okay, next question.
16.
Three long wires X, Y, Z are placed parallel to each other at a distance. Distance given you. Current in X and Y are 2, 4, and 2 respectively. What's the magnitude and direction of the resultant force per unit length? Right? Memorize the formula. That formula. Okay. X and Y. Right? X and Y. You are interested in the force on X. So X and Y. Put in your value. Right? Mu naught. You can take from your value of constant and the current 2 and 4. Distance change to meter. Right? 2 pi there. Simplify. Okay. So this one you must know is a repulsive force. So it's going up. Right? Let's put arrow up. And calculate for X and Y. X and Z, sorry. X and Z. Same formula. Right? 4 pi times 10 to the power minus 7, pi 1, pi 2, 2 and 2. Distance is 2 plus 2 is 4. Change it to meter. Okay, out. Right? This is downwards there. Parallel. Parallel means it's coming down. Force on X is coming down. So you just subtract. Right? Upwards is greater. So the resultant force is upwards. So resultant force upwards, 8 minus 2. Can see.
How do you know it's upward, downward, sir?
Yeah, same direction. This one in opposite direction. So repulsive force going up. Right?
So, and then the other one also repulsive
The other
force
one is
also going
parallel.
up lah.
The other one is parallel. Parallel.
Oh yeah, that one parallel. Yeah.
So it's attractive force. Right? Okay,
So
downwards.
upward minus downward lah.
Ah, okay, one last
Okay.
one. Then we take a short break.
One last one.
That's why you must work on your weakness. Those that you don't know how to do, must work on that.
17.
17, okay. Right, same, you are the same problem. 3 similar long thin wires, X, Y, Z. Current is given. Distance is Y is 20 cm from both X and Z. What's the magnitude and direction of the resultant force per unit length? Right, same. Calculate between, you are interested in Y. Y is the center one. So put in your value. Right, 4 pi times 2 times 1, sorry. I think there's something missing here. Right, times 1 is missing, doesn't matter. And then distance convert it to meter. Right, 1 and 2, 1 and 2. And then distance is 0.2 meter. Right, 2 pi, calculate up. Right, remember this is repulsive, so it's going to the right. Right, there's an arrow there. Same thing for the other one. Z and Y, same formula. Put in your value 2 and 3. Distance 0.2. Simplify, calculate out. Right, this is repulsive force. Repulsive force is to the left also. So left and right, so you subtract. Can see the two questions are almost the same. So you are still very weak in this area. Okay.
Answer is A.
Okay, we'll stop here. 5 minutes break. Then we go to structure. If you haven't done it, you better try it now.
Okay.
Anything else you want to ask?
No, sir.
Okay, then we stop here.